Hello and welcome to your video notes number 2 for Unit 2. Please make sure that your notes are titled. And the first time around, the first time around I recorded this, it was way too long. So I'm going to talk really fast. So please use your pause button liberally during this time so that you can catch up on the notes. We are talking about auxiliary lines today. Auxiliary lines, well, if you've ever passed the aux cord in a car so that you can listen to music, you've also used the word auxiliary at some point in your life. Let's talk about what it means in geometry, and then I'll relate it back to this doohickey over here. So an auxiliary line, I think I'm going to type this. Okay. It's an additional line that is added to support problem solving missing angles. So what this means is it's literally an extra line that you add in, just like you choose where to add it in. For example, say we have two parallel lines going this way, and we're trying to find this angle here. If we're trying to find this angle, given that these lines are parallel, that's what these arrows mean, what we can do if we're given this angle, angle A and angle B, we can actually just add in a line and use angle relationships, angle of parallel lines. And we can find out this weird angle on the inside. But to do that, we have to add in our own line. So this red line here, aux line, is our auxiliary line that we're adding in. So if you see dashed lines, usually it's because somebody is like, I'm having trouble solving this problem. What if I add a line right here? Well, it's like you would ask, can you just add that line? Say, yeah, it's an auxiliary line, and I'm going to proclaim that it is an auxiliary line. Okay. In order to do this, we have to talk about something. We need some background knowledge. So we have 5 examples in this notes, and then this first one is the exterior angle. Exterior means outside. Outside angle theorem. Ta-da, ta-da. Okay. What does this mean? So what we do know previously on geometry, you know that triangles, that says triangles, I promise. Triangles add to 180. All the angles on the inside add to 180. So this angle here is actually the red angle minus 180. Okay? So what else is 180 minus the red angle? Well, this red angle is also 180 minus the red angle equals 180, because you'll just get red angle. So here's a better way to think of this. So with the exterior angle, what you need to know is that angle BCD is going to equal the sum of both the interior angles. So these guys are interior angles. They are inside the triangle, and they are opposite the exterior angle. And this red angle is the exterior angle. Notice it's on the outside of the triangle, exterior angle. I'm going to try to talk fast, remember? So angle ABC plus angle BAC. These two angles added together will always equal the exterior angle. Sometimes this line isn't given, so you have to extend this line using an auxiliary line in order to see this exterior angle. Let's see, how else do we show this? But I think there's another way I was going to show you, but let's be really clear that these are the interior angles, and this guy is the exterior angle. Okay. exterior angle is equal to the sum of two interior angles. I'll write that down. The exterior angle is equal to the sum, which means adding, of the interior angles. You know, I said you're gonna have to use that pause button. This is one of those times where if you need to write this down, press pause, and then meet me on example 2 out of 5. So let's keep grooving. Example 2, we're actually gonna do this problem twice. This is version 1. That's version 1. There's two ways to do this problem using auxiliary lines. So our first step is going to be, let me explain to you what's happening first. Given, this is how, watch how I read this. Line segment AB is parallel to line segment CD. That's what these two lines in the middle mean. It means it's parallel. So what do? Even though they give me little arrows, just for my annotating, when I see that two lines or line segments are parallel, I go draw in the arrows right away. To me, this indicates that these two line segments are parallel. What do we need to do? We are going to informally prove that Z, this angle here, is equal to X plus Y together. And if we look at this and I tell you, oh, by the way, Z is equal to X plus Y, you should look at me like I'm crazy. And you don't have to believe me. We are going to use an auxiliary line to prove that angle X is equal to angle Y. So step one, draw in an auxiliary line. Auxiliary. It's a weird word, but practice saying it. Auxiliary. Auxiliary line parallel to the parallel lines. Let's draw in a color. Okay, green, why not? Here we go. So it's a big green line. Going to draw in a line. It is also parallel to A and B. You know why it's parallel? Because I drew this arrow in on my auxiliary line and it's parallel with these other ones. Let's color code X. X is this angle. X, I'm going to cover up Z by Z. Z is going to be those two angles added together. So if this angle is X, this angle is X. Why? X is equal to X because they are corresponding angles. How do I do that? Push a magic button on this pen. They are corresponding angles in this case. Let's see. If you are wondering what corresponding angles are, please see the video notes previous to this where we go over vocabulary on parallel lines. So these are corresponding angles. Let's talk about Y. Y is equal to this. That means Y is equal to this angle because, for the same reason, they are corresponding angles of parallel lines. Not all corresponding angles have to be in parallel lines, as we learned in our video notes part 1 of parallel lines. You should really write of parallel lines right here. What does this mean? Well, this big angle that I'm going to highlight, this big angle that we are looking for, this angle Z, is actually equal to two angles added together. Which two angles added together? Well, funny you should ask. Angle Z is equal to angle X plus angle Y. And we prove that by drawing an auxiliary line, and using our corresponding angles of parallel lines. Boom, proved it, version 1. Are you ready for version 2? If you need to pause this, pause right now and meet me at version 2, where you have to draw the same figure over again. Go ahead and draw the same figure over again, and now we are going to talk about version 2. Write this down. Same thing. We have parallel lines. Notice this is how I annotate my work. If it says it's parallel lines, I myself have to draw and see that these are parallel lines as well. We're again going to prove that X plus Y is equal to Z, but with a different version. For this step 1, what we're going to do is step 1. We are going to continue the transverse line with an auxiliary line. So auxiliary line means basically we just add in some dashed lines somewhere to help us problem solve. So boom, 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 boom. I drew in an auxiliary line. It's red. How does this help me? Well, I'm going to highlight the parallel lines that I want to highlight. Let's take a look at this line and this line. They're parallel, yeah? Parallel. The transverse line is this. So now when you squint your eyes, you see two lighter colored lines here. They're orange. Sorry if you can't see orange. This angle, angle X, whoops, that's not my pen. It's my pen. Is also equal to this angle X. X is equal to X because they are, that's right, you guessed it, corresponding angles. Corresponding angles of parallel lines. Okay. Now, this Y value is equal to this Y value. Y is equal to Y because of, that's right, not corresponding angles, because of vertical angles. Give yourself a smiley face if you responded with vertical angles. Boom. Stamp. Invisible stamp. What does this mean? Good thing in example 1, we learned the exterior angle theorem, where angle Z, oh, let me highlight a new line here. Let me see if I can get rid of this orange line. Oh, I got rid of too much. Okay. Let's highlight this. Oh, pink. Oh, that pink. Yeah, yeah. You see this? Okay. This is the angle I'm looking at. Angle Z is now equal to the interior angles because of the exterior angle theorem. Theorem. Boom. It's also true, and that is version 2. If you need to write this down, pause. This is a good time to pause. Meet me on example 4. We have 2 more examples to get through, and I'm talking a lot faster than last time I recorded this. Go ahead and sketch this into your notebook, and if you just think we're going to add these 2 angles together, you were not paying attention. Actually, it kind of means that you were paying attention, but not close enough. Here we go. We're going to solve for x. So you can choose version 1, version 1, the first way we did it, or version 2. You can look in your notebook, and whatever version that I do, you should do the other version to practice. Did I spell version right here? It looks so weird. Okay, let's do it with version 1. Let's draw in a parallel line. Now, let's zoom in. Enhance. Enhance. Okay, this X is actually going to be both of these angles added together. They're adjacent angles, so we can add them using our angle addition postulate. So let's figure out what these 2 angles are. If this is 50 degrees, we have parallel lines here and here. So if this is 50 degrees, then this is 50 degrees. If this is 100 degrees, this is what? This is not 100 degrees. This is not 100 degrees. It's an acute angle. But this says 100. Oh, right. Boom. 80 degrees. Why? 80 degrees and 100 degrees are, what are they called? Consecutive angles. Also means they're supplementary. Oh, if you're wondering what consecutive interior angles, I think, interior, oh boy, move. If you're wondering what this word is or how I knew that they were supplementary, Please rewatch video notes number 1. Short video, but goes over a lot of vocabulary that we're going to need for this unit. Okay, that was the only tricky part. Here's another way you can think of it. If this is 100 degrees, this is 80 degrees, and then these 80 degrees are corresponding angles. So what does that mean? Angle X is equal to our 50 degrees plus 80 degrees, and you can figure out the rest. I'm not going to do that. Go for it. Boom. If you need to pause this, you should try it with version 2. As a reminder, version 2 is if you extend this line out, and then you can add in the interior angles. So you need the exterior angle, which is what you're looking for, and you have to add the interior angles. Okay, have fun. All right. Last example, I promise. If you got this far in the video, and you've been paying attention, you've been taking notes, then if you finish out this problem, you're actually going to have an advantage to your other classmates because this is an unfamiliar problem and it takes some thinking and some risk taking as well. All stuff that I checked if you were able to do this at the beginning of the year. You all checked off, yes, you are risk takers and problem solvers. So here's an example of one of those. This video is intended so that you can watch how one person would think through this as an example so that you maybe can apply the risks that I take into future problems. Given that, in the figure to the right, prove that D is equal to A, B, and C. So watch, I'm going to scan this problem. Angle D, this one, this is our find. We're trying to find this. Notice I'm annotating. And angle A, B, and C. All I know is that angle A, B, and C are all interior angles because they're inside this polygon. It's not really a triangle. It's not really a square or a rhombus. It is a quadrilateral of some sort, but all I know is that A, B, and C are interior angles. And we did learn something about exterior and interior angles. That might be a clue. And auxiliary lines. If you're ever at the point where you're just like, I have no idea where to start, here is one of the good problem-solving skills that you can apply in your toolbox. Draw auxiliary line of some sort. Here's the difficult part. Sometimes you're going to draw an auxiliary line because you're going to be like, I don't know, this way. And it might not lead to anything. But check this out. You don't even have to erase it if you don't want. I might erase it just because if somebody tuned into the video now, they might be confused. But you really don't have to erase it. I like seeing your work. I like seeing the risks that you take, and then you can explain from there. Okay, like I said, angle D looks like it's the only, this says find. It looks like an exterior angle because it's on the outside of this polygon. So why don't I try to make this look like a triangle that has an exterior angle of this? So what if I drew in an auxiliary line like this? I have no idea if this will lead me anywhere, but I just drew in an auxiliary line from C to D. So I'm okay. I know that this angle here, I'm just going to call it another letter. Angle D is equal to Z plus A. I know this. This is my exterior angle theorem. I'll write it down. Here's what else I know. What's odd is that Z is also, it's coming back. Z is also the exterior angle theorem of this triangle here. So let's see if that'll get me anywhere. So Z is the exterior angle of angle B plus C. I made up, just like I made up an auxiliary line, the auxiliary line led to this auxiliary angle of Z. But here's the thing, if this is equal to Z, B plus C is equal to Z, and this is equal to Z, then what I should be able to do is substitute the technique you learned a lot and practice a lot in Algebra 2. It works in geometry as well. If you substitute B plus C, then you also get the same thing. And you can switch around the letters because there's something called commutative property of addition, which you learned about in Algebra 1. And then you would get what the question asked for. That was kind of weird. It took a little bit of creativity, it took a little bit of risk taking, and it may not have happened the first time around. So at this point, if you need to pause, catch up on the video, if you have questions, if you're just like, how did you know to do this? Please document the questions, and then you can report these questions back to your teacher or ask a neighbor or ask an academic coach, somebody to help you out. But at this point, there comes a time in the video where I stop talking and you write your summary. What were the most important parts of this video? Go back and check that you have all the appropriate vocabulary, and see you next time. Bye.